Hi, Chem students. Welcome to today's lesson over valence electrons. So valence electrons, they're the electrons in the outer energy level of an atom. We say that they're like the front lines of an army because they are the ones involved in chemical reactions. Valence electrons are shared or transferred during these reactions. The number of valence electrons that an atom has is directly responsible for an atom's chemical behavior and reactivity.
I want to go ahead and remind you of what a segment of the electron configuration looks like and what it stands for. The number in front is the energy level, which correlates with the period on the periodic table. The letter is the sublevel, and then the exponent is the number of electrons within that sublevel. So, the number of valence electrons can be determined from the electron configurations. What we're going to do is we're going to count all the electrons in the outer or the highest energy level for that atom. So starting with lithium, we've got 1s2, 2s1. Okay, 1 is a very low energy level. It's the lowest one on the periodic table. 2 is higher. So how many electrons are in that energy level? There's only one electron. So it has one valence electron. One electron in that outer energy level. Beryllium, 2 is the outer energy level with 2 valence electrons within it. For beryllium, 2 is the outer energy level. Now it's in the S and the P sublevel, so we have to add those electrons together. That's 3 valence electrons in the outer energy level. So this pattern continues. With carbon, we've got 4. With nitrogen, we have 5, oxygen 6, fluorine 7, and neon has 8. So for the dot structure for these, what you do is you just write the symbol. So I'm going to write all my symbols first. Okay, so you have a symbol, and then you represent with dots the valence of electrons. So with lithium, there's 1 valence electron. Beryllium, there's 2. So I like to put the dots opposite of each other. With boron, there's 3. So I kind of just go clockwise. With carbon, there's 4. Okay, after you have 4, then of course comes 5. But you go around once, and then at 5, you make your first pair. So the rule is at 4, you go around once. You should not have any pairs 1 through 4. But at 5, you'll see your first pair of electrons. Okay? At 6, we're going to have 2 pairs and then 2 that are single. For fluorine, we've got 3 pairs and then 1 all by itself to make 7. And for neon, you'll have 4 pairs, making a total of 8 valence electrons. That's just the pattern you should follow when drawing your electron dot structures. So the number of valence electrons for the representative element groups follows an easy pattern from 1 through 8, going across the periodic table from left to right. You should the pattern. It's easy. 1, 2, 3, 4, 5, 6, 7, 8. There is an exception to this, though, and that's helium. Helium only has 2 electrons. It's impossible that it would have 8. So helium, on some periodic tables, will actually be located above beryllium. Okay, notice that the elements in a group, also called a family, all have the same number of valence electrons. For example, group 1 elements, known as the alkali metals, all have 1 valence electron. Therefore, they will behave in very similar ways. So try this. Find an element on the periodic table that has the same chemical reactivity as sulfur. Here's sulfur. So this is very easy to answer. Any element in the same group will react the same. So oxygen is a very good answer for this.